Hi there! Ever wondered why Eurocircuits is investing so much time and effort in virtual PCB production tools? Well, bear with me and find out. You, our customer, are predominantly an electronics engineer. Your designs are electronic applications, which you would like to build to test them. Together, our goal is to do this right first time. Virtually simulating the production allows us both to examine future results before we physically build anything, thus saving time and money. Until recently, our PCB Visualizer tool allowed you to do all of this for the bare board. Customers using our PCB Visualizer tool experienced tremendous efficiency increases in the prototype ordering process, as they avoid unnecessary mistakes that were flagged up after their PCB was visually presented to them, including all DRC and DFM info for the bare board. Now we have taken this philosophy one production step further and are presenting our new Assembly Visualizer. Visualizing the components on the bare board allows a whole new set of design rule checks and design for manufacturability checks. Imagine the PCB you designed arrives at the EMS company, where in the meantime all components were prepared to start building the prototype. One of the component footprints does not match the copper pattern on the PCB. This will result into massive time loss and extra costs. One of our beta test customers faced the following problem. He designed the component in his CAD package, but defined the footprint seen from the bottom to the top. He then placed the component on top of the board, and thus it was placed mirrored. Since it was an asymmetric component, a solution could not be found, and the bare board needed to be remade. At the first glance you might think that your CAD system would flag up this mistake and warn you, but that is not the case. The component had the wrong definition of footprint, preventing this warning. Such a mistake can only be found by checking against a second source. Companies offering electronic manufacturing services know these issues, and that is why for every quoted job they take the time to fully analyze your bill of material, called BOM list, your component placement list, called CPL, and the bare board data. By doing this, they are not only trying to find out all possible technical issues, but are also checking your BOM for availability, price of component. This job preparation takes a considerable amount of time and involves communication between the EMS company and their customer. The extra cost factor is a heavy burden on prototype and small series assembly, and the main reason for the lack of offerings of these services in the market. So designers are solving the issue in-house by doing the production themselves, many times facing the limits of what still can be manually mounted. We strongly believe that there is a market for prototype assembly, if we can help designers to prepare better data for board and assembly. The help we offer is called Assembly Visualizer. It contains two main things. On one hand, a database of verified components. We will not only check the sourcing of these components, but also their technical description, naming, IPC coding, footprints. Now the footprints are based on IPC recommendations, but in a later stage we want to incorporate recommendations from EMS companies. We will introduce the idea of generic parts. For standard components you might not be interested in the manufacturer, only the correct specification, the correct package, the correct footprint. In that case we call this a generic part, which has several equivalent parts from various manufacturers. You can use these in your BOM list. This makes it clear for the assembly company that they can choose any of the components specified as equivalent for the generic part. When using this database, our customer is assured that his BOM list will be clear and sourceable. Secondly, we create a set of visual online tools. First is the BOM editor. It analyzes your components, showing availability and price. Then we have the CPL editor, which places your components on the bare board, showing all DRC issues on footprint description, location and rotation. Further, we need a communicator called the EC communicator to facilitate all the communication between the EMS company and you as a customer. Then we have a generator for output, because you want to output a validated BOM list, a validated CPL list, and 3D data of the board. We have set up a demo session that will clarify all of these issues for you. Wim, our head of development, will guide you through our new Assembly Visualizer process. Over to you, Wim.
Okay, let's demonstrate some of the functionality now. We have prepared a dataset which contains two BOM lists. First of all, a CSV file generated directly from the CAD system with very little information in there, and an Excel sheet generated by the designer containing more information like manufacturing part number and supplier part number. Let's first take a look at the result if we read in the CSV file. You can see that automatically the file is analyzed and columns are identified. This is done because the system is self-learning and this type of file has already been submitted. Of course, you can manually overwrite these settings by, for example, assigning a different column identifier to a column. As you can see here in the file, there is very little information available to identify a part. Just a package name, a very short description, and for some components we have some more description and possibly a manufacturing part number. Let's see what happens if we submit this file to our search system. Each of the lines in the file are now sent to the search system, and components are either not identified or identified. You can see that a lot of them have not been identified. You can use the search functionality to correctly identify a part. So you can perform a manual lookup, for example, for supplier part number if you have this information available. You get a search result. Look at the data sheet to verify if the correct component was found. If so, you can just accept the selection by double-clicking. At this stage, you have to check all the components to make sure that all of them are identified and all of them are correct. Now let's move to the next step of the functionality. Now we check the information about component footprints against the board information we have available. So now we go to the component placement list information. Here we are using the board information we have available. In case we get the information as a Gerber file, the only information we have available is the position of the copper pads that are free of solder mask. In case, for example, we get an equal BRD file, we have extra information like which copper pad is linked to which component and even which copper pad is to be considered pin 1 for that specific component. Let's take a look at, for example, IC2. You see that this component is marked in red because a number of checks have been performed by comparing the information from the database about this component and the information on the board. It's marked in red because the theoretical component pads do not match the copper pads. This is indeed correct because there is a rotation issue here. We can correct this by rotating the component 90 degrees to the left. As you can see on the screen, everything looks okay now, and the component is now marked in green. So problem solved. Another possible issue here can be shown with IC5. In this case, the component placement list did not contain the centroid position of the component, but the pin 1 position of the component, where we expect the centroid position. We can use the offset function to change the position of the component. Since we have information available about the component pads, we can snap to them to correctly position the component in the center between the top left copper pad and the bottom right copper pad. This way the problem is solved and this component is now also shown in green. Another item we can show, or a possible error that we can demonstrate, is here with CN2. As you can see, to start with, this component is incorrectly rotated. So let's rotate this component 180 degrees. Rotation seems to be correct now, but the copper pads do not match. Let's try to position it on the center of the information given in the legend layer. If we do that, we see that now the bottom row of pads almost matches correctly between the theoretical information and the copper information, but you see that both top pads do not match and cannot match, so there is a mismatch between the copper footprint and the theoretical footprint. This can have a number of causes. It is possible that an incorrect component has been chosen in the BOM analysis, so we can go back to the BOM analysis to open up the datasheet to check whether the correct component has been chosen and, if necessary, modify it. Another reason why it can go wrong is worse. Could indicate here that the CAD library for this component does contain an incorrect footprint, so this means that this board cannot be assembled with this component. You have to go back to the drawing board to correct your component footprint in your CAD system and resubmit the data for analysis. This analysis can be done before the board is being ordered, so before the board is being produced.
Thanks, Wim, for the nice presentation. Hi guys, welcome back. I hope you enjoyed Wim's demo and that the entire issue of virtual PCB production has become clearer for you now. We are convinced that if your design is processed through our PCB Visualizer and Assembly Visualizer, thus offering you a validated BOM and CPL, the access to electronic manufacturing services for your prototypes in small series will be easier. Unnecessary overheads are avoided and machine setup times are shortened, thus allowing EMS companies to make money with smaller orders, which will be better affordable for you, our designer customers. Our database of verified components will shortly be made available for our customers in various CAD system formats, namely Eagle, KiCad and Altium. Using these verified components will significantly shorten the processing time through Assembly Visualizer, as your BOM list will be understood, clear, and your components will be available and they will match their board. Building a component database is a huge task. Our aim is not to manage all the components, but to do so for the current components. Our Indian team of engineers started to build the database, currently based on BOM lists that our beta test customers are uploading. Each time a new part is selected from a supplier database that we can access, the part description and the footprint are first verified and then added to our database. We are not looking for all possible parts, as we do not want to build a historic database of components, but a database of components that are currently being used by our customer. The number of orders passing daily through our system guarantees that our database will have the potential to grow rapidly. Soon we will release the beta version of our BOM editor and Assembly Visualizer, supported by a yet limited component database. This will be the kickoff for the process of filling our verified component database. Until now, our customers are used to only supply us with the bareboard data. But we invite all to participate in our beta process and from now on to upload the BOM and CPL files together with the bareboard data. This option will be available daily until we have reached our daily capacity for BOM processing. Participating in this beta phase will assure that your BOM and CPL specifics will be covered by our system once we deploy it, and that your components are verified and are in our database. Our engineers will analyze your BOM list and add all missing parts and footprints to our database. After analysis, the Assembly Visualizer will be available in your online account in the Running Orders section. You can then view your PCB, including the components and all DRC results. Your PCBA prototypes in small series, right first time, is our goal. We hope you enjoyed this presentation and like to meet you again in the near future. Thanks and bye.